like I said, you've got your vertical height, and you have your slant height. Vertical height goes to the center, and these are really tough to draw, and I don't expect you guys to draw these things really well. This out to the side would be an apothem.
No, this is kind of confusing.
Okay.
This
And what I want you to be able to do here is think of these. This is just, here's the base. Okay, there's the base. This is the vertical height. This would be the slant height. And this is the apothem.
What's your opinion on?
And I'm just trying to piece this together a little bit because the worst thing that happens with pyramids is that sometimes you get lost in which part is what. So by just deconstructing the picture to show that you have a base from whatever shape it might be, every base is going to have a vertical height. That vertical height goes to the center of the base. From that center to a side is always going to be an apothem because it'll be the perpendicular bisector of a side. It's just a lot of vocabulary thrown into a shape, okay? The math is easy. It's just making sure you understand where things are in the actual object themselves, okay? So with this, we get a really basic formula. The surface area of any pyramid is going to be the area of the base plus 1/2 the perimeter of the base times the slant height. And we use the cursive letter L for slant height. So big B, I know, right? Big B is the area of the base. And I want you to think regular polygons. P, perimeter of that base. And then cursive lowercase l is the slant height. Those triangles going around, the triangles going around the base here, these are always going to be equilateral.
That's the perimeter of base?
Of the base, yes. All these triangles going around will always be equilateral. Okay, they're always going to be equilateral. They might be, not equilateral, I'm sorry, they're going to be isosceles, excuse me. They might be equilateral, but they will definitely be isosceles for certain. Equilateral if you're lucky. Okay. Exciting. Very exciting.
Do you like flatland?
Don't even know what that is.
Or what is it called?
Isn't that like the Donald Duck something or another?
No, is it flat world? Do you know what I'm talking about? It's like the different dimensions.
It's not cold.
Oh, just two-dimensional plane?
No, it's like a book.
What? Sorry.
That's the who always played it.
Okay. So let's look at an example with some very straightforward numbers. In this case here, this didn't go through. In this case here, this is a regular polygon base, and if I give you one side of 10, that means what are all of the sides?
10.
They're 10. Because these pyramids are going to be regular polygon based. So if it's got 4 sides, it means it has to be a square. Okay? It's not going to be a rectangle anymore. Trust me, drawing these things it's very difficult to do. So when I do these problems, if I don't have a picture in front of me, I'm just going to write down what everything is, just like we have been, really. Because some of these diagrams are a bit of a pain in the yeah.
Is 5 the base?
Angle side side.
But there is no.
But-
Is 5 the base of the
Yes.
Alright, cool. So you can do math.
Wait.
So what's happening here is that you would just, the way that I would go about these, since it's a surface area problem, I would start with, hey, it's surface area of a pyramid. which is area of the base, half the perimeter, times the slant height. I start with that, and then I draw, or I write down what is my base. My base is a square, which in this case is 10 by 10, so I would just write 10 squared, or 10 times 10. And just like you said, it winds up being 100. It's quick, okay? From there, you can do the perimeter. Since it's a square, it's got 4 sides of 10. Well, last time I checked, 4 sides of 10 equals how much? 40. Okay. The last thing you have to find out then is that slant height. Now, when you look at this again, you get this right triangle. The vertical height was the 12. This to the side is the apothem, which would be 5. Now, you can do a whole bunch of stuff with that, but just so you guys remember that out to the side is always going to be an apothem. That gives you a slant height. You just have to use Pythagorean theorem to find it. Okay? If you use Pythagorean theorem, you get 5 squared plus 12 squared. It actually is a triple, which is
Oh, yeah, it's 13.
13.
Yeah,
Okay.
that's what I got.
If you don't remember triples, that's fine. It's not that big of a deal. You can just use Pythagorean theorem, and it will still work. You'll get 144 and 25, which is 169. Square root of 169 is 13. And that gives you that slant height.
I have a question.
Yes, ma'am.
When you write this all the way out, would you put the parentheses around the P and the
Yeah, this just shows that it's multiplied.
Okay.
Okay. So when I go to write all this out, then we know it's perimeter. The area of the base, which is the 100, plus 1/2 of 40 times 13.
I got 360.
I agree. Okay. 360 something squared. Because it's surface area, so you have to remember to, or units. Yep. Okay. Now, remember, when you're putting this stuff in the calculator, a lot of times I separate when I do multiplication on the board. I use parentheses to show it. You don't have to use the parentheses. You can just hit times. It'll work. Because sometimes people just use the times because it's easier to write. So I do 100 plus 5 times 40 times 13. I get 360 something squared. Please, 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 please write down what you're about to put in the calculator before you do it. That's wrong, it's fine. You want to do that? Ask me a question. What's the motto? You've never heard that before? I can only imagine that I was the first person to think of
And
it.
I'm asking.
What's up? What do you got?
She's confused, Mr. Murphy.
I'm wondering. Yeah.
Look, Pete.
You wrote it down, right? But you just accidentally subtracted it. Now here's the thing. What happens if you did that on a test? It would be wrong, but you wrote down everything that you did. You know, I would probably be like, hey, doofus. And I would probably write that, hey, doofus. Is it D-U-F-S?
No, it's double O.
Or
Yeah, it's the, hey, Mr. Murphy, you should have came to this
I'm sorry, I was a spelling bee champ.
And I did really good.
I apologize.
I was.
My in-laws were in town.
What grade?
Grandma and grandma. So we're out to dinner with grandma and grandma.
Trophies!
Okay?
Arson, everyone went to the
Come. Let me do this real quick.
I know that man is.
Oh, great, you broke the smart board.
Yeah, story of my life. There we go. Now, yes, ma'am. Hold on. What's that? Yes. Now, what I want to show you guys here real quick, the difference that we're looking at between pyramids and cones. Just like when we talk about prisms, the pyramid was the area of the base half the perimeter times the slant height. Well, when you have a cone, I thought I had a picture of a cone. Let me do this real quick. When I have a cone, what's the base of a cone? It's a circle. So when I do this, the base of every cone is always a circle. Well, what's the area of every circle? Pi r squared. So big B for a cone will always be pi r squared. Okay. Now, when you're looking at it in terms of perimeter, the perimeter of a base is the distance around. Well, how do you find the perimeter of a circle? What's that called? Circumference. Good. Circumference is the perimeter of a circle. Circumference is 2 pi r. So big P for the perimeter would be 2 pi r. Now watch what happens when you start putting all this together for a cone. If big B is pi r squared plus half of 2 pi r and a slant height, what's always going to be half of 2? 1, no matter what. So what we do is, the formulas are exactly the same, but what's different with the cone, it's easier because you only have to worry about a radius. Okay? So whereas the pyramid, you have all these different types of bases, in a cone, the base will always, always, always be a circle. Yes, ma'am?
Usually when we do this, pi starts off at the beginning, but when we get to the number, why do we move it to the end?
Etiquette. It's math etiquette. When in the grand scheme of how you write stuff out, numbers, symbols, variables. Okay? That's how things would be written as things go along. So that's why we say it's 2 pi. But the
So
minute...
when you, so when you plug it in, would you put the pi before or after?
After.
In the calculation?
Correct. It just switches it up. It's just the math etiquette way of writing it.
Would it give you a different answer if you think so?
It shouldn't, but it depends on how crazy the radius value is. If it's non-decimals, you should.
Oh, okay, I was just, wondering.
So this will always be 1. That will never change, which will always give you the value, or excuse me, the surface area of a cone will always, always, always pi r squared plus pi r L. And that L is still that slant height. That L is still going to be this value on the side here. It's still going to be that slant. You're still going to have a vertical height, and your apothem now becomes a radius.
Who comes up with these
Crazy people.
things?
Okay. Now, I told you guys this on Friday that I had a formula sheet for you so that we don't have to, obviously, not making you memorize any of these things. But this is going to be the formula sheet for the final. Well, a different version, obviously. But these are all the formulas that are on the final. What's that? You'll get a fresh one. Okay. So the formula sheets that you get on the final will look like this. These are all of the ones that are on there. So that way, as you're starting to prepare and starting to work through stuff, you know which formulas that you'll be given, but yet you'll know what you have to remember. So I made a copy of what it will look like. 3-hole punch if you want to throw it in your binder. That way you've got all of your formulas in front of you, because really all of 12 is formulas from all of 11. Okay. I know, right? So let's look at an example. I'm sure I didn't want to count because I get lazy. Yes, ma'am. I emailed it to you 2 weeks ago. And we talked about it in class 2 weeks ago. And yes, they are 3, 2, 2.
What's 3?
No, is it 3, 2, 2 or 2, 3, 2? 3, 2, 2. Yeah, 3, 2.
I thought it was 4, 5 hours.
Okay. So
Thanks, man.
example like this, we've got a radius of 6, a vertical height of 8, which means you got to find your slant height. Well, remember, the vertical height to the radius. Yeah.
When the sand height is up, so it will be like 6 squared.
Exactly. And you just keep using that right there. Okay. So it doesn't get to be overly math involved for a lot of this, but usually you're going to have at least one extra step that you'll have to take care of as you're doing these problems. Whether it's a perimeter apothem base, or it's using Pythagorean theorem real quick, something along those lines.
So would that whole thing be code?
Nope. 6 squared is how much?
No. I'm talking about the whole. what
The
you call it,
diameter?
of the circle.
Yeah, the diameter would be 12. Yes. Do I need the diameter
No,
for?
I was just asking because sometimes I get confused.
Gotcha. I thought you were talking about the slant height. Okay. What's my slant height for this? 10. How? 6 squared plus 8 squared is 100. Square root of 100 is 10. Sir.
Alright.
So you've got pi r squared. Well, 6 squared pi plus 6 times 10 times pi. $96 pi something squared. Cones are the easiest thing that we work with. Because it is so unbelievably straightforward.
Okay, now your homework for the night is.
No, I want to still walk you through a perimeter apothem problem, and I gotta walk you through a triangle one. It kind of gets.
You're good.
Mr. Murphy,
Yes, sir.
I can't help but notice that this says semester 2 final exam for us.
Yeah.
Are we going to be able to use this on the final?
I've already discussed that on multiple occasions. Okay.
Good answer is.
I've already discussed that multiple occasions. Yes.
I already asked on multiple occasions.
Yeah. Sorry, this is the slant height here. The slant height is 14. Yeah. Don't draw that. Don't draw that.
Did you hear my name for it? Is the trichromatic?
Yeah. If I'm going to find the surface area of that, it's a pyramid. Okay. The pyramid itself. Remember, we start always by writing down the formula. Well, surface area of a pyramid is always area of the base, half the perimeter of the base, times the slant height. The shape of the base here has 6 sides, which means it's a hexagon. It's regular polygons, it's a hexagon. So big B means it's going to be a 1/2 perimeter apothem problem. Whenever we did that, we did 3 sides. Okay. We did the 3 sides. And I was discussing this with first hour, and I retracked where we started doing this. We started doing perimeter apothem problems May 2nd. We've been working on them for every day for the past 2 weeks. So this setup, this problem, shouldn't be an issue by now because we've done a gazillion of them, and that means a lot. Perpendicular bisector of the side, 12, 6, 6. Outside angle, take 360 divided by 6, gives you 60. It gives you 120 on the inside, leaves you another 60. 30, 60, 90, very good. Do you have to use 30, 60, 90, or could you use tangents?
You can use whatever you want.
You can use whatever you want. Honestly, I would suggest going this route because it's quicker. Okay. Now you know across from which angle? which is 6, which means that is 6, which makes your apothem 6 root 3. You have 6 sides of 12, that gives you your perimeter. Okay. So you start piecing this together. Your big B is 1/2 perimeter, which is 6 sides of 12. Apothem, 6 root 3. That gives you big B. Perimeter, we just wrote that down. 6 sides of 12. The slant height we got from the diagram. It told us it was 14. So we put it together. Bless you.
Hey, we signed up for like
There's big B. I just haven't gotten to put anything in my calculator in. I don't have to put it all right away. I can just leave it like that. To that, I add 1/2 the perimeter. Times the apothem. And then I start typing things through.
Wait, how we get 14?
It was in the diagram.
Oh.
It was given, yeah. It was given. This one was given. To be honest with you, when you get to this part now, just like I've been saying, please be sure that you write down what you're about to type in the calculator before you do it, okay? Because one of the mistakes that I know that people make at this part is that as soon as you open up that square root symbol, you have to hit the right arrow to get out from underneath it. A lot of times people will hit square root 3 and they'll forget to hit the right arrow and they'll hit plus all that other stuff. Okay? It is a very, very common mistake. So we put this here, it's 1/2 of 6, 12, and then 6 square root 3. See what I mean? That if I don't hit the right arrow, I'll still be underneath the radical. That's why you have to remind yourself, and then you hit plus. And with any luck, 878.12 something squared?
Yeah.
Does that sound about right for you guys?
Yep.
Like I said, it's formula work. It's a lot of formula. Yes, sir. Not a clue. Yes.
Sign language. Or nature.
Okay. Let me show you the difficult one then. The goofiest one that I can think of.
ooh.
You just had
No.
this right.
That was good though. I'll give it a little credit.
No, you can't
Hey,
do
no offense, but it was funny.
No.
The goofiest style problem.
Good job.
All right, the goofiest style problem that I can think of is when you have the equilateral triangle base. All right, this is the one that takes a little bit more time to get to understand what in the world is going on. Now, when it says you have a regular polygon, height of 10, and a base that's an equilateral triangle with base edges of 12, that means
That's the base.
that. Well, at least I could try to draw those. These are the 12s. Okay, the base is 12. All right. Somewhere in here, you've got that centerpiece. Okay. Somewhere in there, you've got that centerpiece. Yes, sir.
So the formula for a pyramid is the same.
Not quite. The big B just stands for the area of the base.
So like
Now, real fast before we get in here. This spot is what? It's the center of it. If I draw this to a side, what is it? It's the apothem, right? Now, when we're thinking about this, if I went up from here, it would be my height, right? So what I'm going to do real quick here is draw this off to the side, because I know that that's my apothem. I know that the vertical height here was 10, and that does that. Are we okay with that? Now, we could actually figure out that apothem and do perimeter apothem with an equilateral triangle. It's not something we normally did, because we would just do 1/2 base times height and do that. But in this case, it actually works out a little bit cleaner. Let me put this part here on a different sheet so I have a little bit more room. And like I said, this is about as weird as these can get. Normally, when we do regular polygons, we do the 3 sides and go through it. I don't need to do that with a triangle because we know what all of the angles measure. What does each one of those angles measure? Yeah, they all measure 60. Okay. So that's a 60. Now, if I draw that in, what do I do to that angle?
Cut it in half.
Which makes it 30. I have a 30, a 90, and a 60. Now remember, the apothem is the perpendicular bisector of the side. Okay? You've got your 30, 60, 90, but now you know across from the 60.
You got that thick.
Okay? If you know across from the 60 and it's equal to 6, that means that something times the square root of 3 equals 6. What's the something? How do you undo times? Divide. So if you take 6 divided by the square root of 3, you get 2 root 3. Are we okay with that? That creates your apothem.
Yeah, I was about to say.
So there's a couple of ways that you can get the area of a triangle if it's equilateral. One of the ways is still to do the perimeter apothem. The other way would have done the whole draw the perpendicular bisector to the side, get the vertical height, all that kind of stuff. But then you still had to go back and get the apothem anyway. All right. That's why it's important to understand why I was showing you guys what do all these parts mean if you were to turn it around. You'd have that pyramid with that vertical height coming up to the sides. Okay. Excuse me. So that means you have a 1/2 perimeter apothem problem. What's the perimeter of the triangle if all sides are 12? 36. So your big B is 1/2 of 36. Apothem, 2 root 3. Perimeter of the base, 36. But we still need that slant height. It gave us the vertical height, it was 10, I believe. We know the to the side. Go back here.
Wait, when did you do this?
Nope.
Oh.
So going back to figure out that sine height, that's why I redrew that triangle to begin with. Because I knew that if I found my apothem, I've got one leg of the triangle. I know the vertical height's the other leg. Pythagorean theorem. 10 squared is 100. The quantity 2 root 3 squared is 12. That makes that slant height the square root of 112. Or 4 root 7, I believe it does. Yes, sir?
So that's like, that triangle is like,
Yeah.
that kind of, I don't know how to say.
They're tough. That's why I wanted to just take a couple minutes and do a triangular one, because those are the screwiest of them all. So using Pythagorean theorem, you get the square root of 112 here, which would be full root 7 as you do it.
And then that's when your ace managed commercial comes in.
So put it all together. Half, 36, 2 root 3, plus half, 36, 4 root 7. And if you do type that in correctly, I think it should wind up at 252.85. At least that's what I got.
Yeah.
It's the idea of making sure you label it through correctly. Okay?
That'd be so funny.
You got it. And it does that because of all the radicals are in it. All right, so if your calculator gave it to you with the radicals in it again, just hit double arrow.
I just want some ice on my wrist.
Okay? The first 3, you're given everything. The second 3, you're given a diameter once. Oh no, you gotta cut it in half. And then the last 4, you just draw a picture of what the base is in the slant height. You might have to do a little bit extra math. This might take you 20 minutes, if that. Okay? They're pretty quick.
Have you ever heard that song?
20 minutes?
I already got some good designers in on that one. And then he says,
Gonna go ahead and say no.
I just want some ice on my
20
wrist.
minutes is not 10 to 11.
Oh, I get pretty much.
20 minutes is 10 to 10:20.
No, this